before watching this video, please make sure that you have already watched the previous videos. In this session, we will be learning various methods to solve the differential equation. In this session, we will be learning the first order and first degree differential equation. We already know the first order and first degree differential equation contains dy by dx and the terms involving x and y. Therefore, the general first order and first degree differential equation will be of the form dy by dx is equals to f of x comma y, where f is a function of x and y. So throughout the session, we will be discussing the first order and first degree differential equations only. So dy by dx is equals to, now there are various methods to solve the differential equation. They are variable separable method, homogeneous differential equation, non-homogeneous differential equations, and linear differential equations. So these are the various methods to solve the differential equation. So let us first discuss the variable separable method. So variable separable method, if a differential equation is of the form dy by dx is equals to f of x into g of y, or dy by dx is equals to f of x by g of y, or dy by dx is equals to g of y by f of x, etc. Then, according to the variable separable method, the method clearly says that we have to separate the variables. What are the variables here? X and y. We need to separate the variables. So, as far as first situation is concerned, here dy by g of y is equals to f of x into dx. So that means all the values of all the variables of y came on to LHS and the x terms went to RHS. So therefore in this way we could separate the variables. Otherwise, if the situation is something like this, then this is g by dy is equals to fx dx. Otherwise, this is dy by g of y is equals to dx by f of x. So, in this way, we can separate the variables as the name clearly suggests. And the second thing that we have to do is we need to integrate on both sides. And in this process of integration, so the constant will be added, since it is a indefinite integration. So here one constant will be added, another constant will be added onto the RHS. Instead of adding the constant on both the sides, so let us add constant on any one of the side. Okay, so that is the required general differential equation which we are looking for. So in this process, so the answer will be varied from the actual textual answer, because there are so many things involved which we can learn in solving the problems. So let us start the exercise 8b. Find the general solution of root 1 minus x square dy plus root 1 minus y square dx equals to 0. Solution. So let us transpose one item on the other side. So given differential equation is square root of 1 minus x square dy plus square root of 1 minus y square dx is equals to 0. So this is 1 minus x square dy is equals to root 1 minus y square dx. This is dy by separating the variables, we get see that dy and dx will be on the numerator. So dy by, if you transpose 1 minus y square, it is getting multiplied with dx. If it come, it will be dividing. 1 minus y square is equals to, this is minus dx by root of 1 minus x square. So this is equals to, now integrating on both sides. Integrating on both sides. This is equals to integral dy by root 1 minus y square. This minus if you take on to this side plus, otherwise, okay, this is minus dx by square root of 1 minus x square. This is equals to integral 1 by root of 1 minus y square dy is sine inverse y. Integral 1 by 1 minus x square dx is sine inverse x. So this is sine inverse y plus c1 is equals to minus sine inverse x plus c2. I already told, instead of adding these two constants, so let us add only one constant at the end. So this time, so sine inverse x plus sine inverse y equals to minus sine inverse x plus the last step, actually we add c onto one of the sides, any one of the sides. Now therefore sine inverse y plus sine inverse x is equals to c. So this is the required general solution. Find the general solution of dy by dx is equals to, so here given differential equation is dy by dx is equals to 2y by x. Separating the variables and integrating on both sides, we get, this is dy by 2y is equals to dx by x. Otherwise dy by y equals to 2 dx by x. We can write in any way, integrating on both sides. This is 1 by y dy is log y. 1 by 2 into 1 by x dx is log x plus c. So the constant of integration may be added in any one side. So this is equals to log y plus log c is equals to 2 log x. But c can be taken as, since it's a constant, we can even write c to be log c. Now log a plus log b is log ab. So log cy. So n log a is log x to the power of 2. So therefore if you remove the log on both sides, x square equals to cy is what we are getting as the required general solution. Second Roman first question, solve the following differential equations. So the first question given is dy by dx is equals to 1 plus y square by 1 plus x square. So this is the question given. So we need to differentiate. The difference between this question to that of last question is same. So he has clearly asked the general solution. Here he has asked to solve. So both are the same. Now separating the variables and integrating on both sides. Then this is dy by 1 plus y square is equals to dx by 1 plus x square. Separated the variables. Y on one side, x on to the another side, and integrating on both sides. So this is equals to 1 by 1 plus y square dy is tan inverse y is equals to, this is tan inverse x plus constant to be added one of the either sides. So actually here c I will be adding on to the RHS. Instead of this I can even write tan inverse c also. So or we may write like a tan inverse y is equals to tan inverse x plus c, or tan inverse y plus c is equals to tan inverse x, or tan inverse y equals to tan inverse of x plus tan inverse y. So tan inverse a plus tan inverse b, tan inverse of a plus b by 1 minus ab. So c plus x by 1 minus cx. So if tan inverse is removed on both the sides, then y is equals to c plus x by 1 minus cx is what we are getting. Otherwise y into 1 minus cx equals to c plus x, or tan inverse y minus tan inverse x is equals to c. Therefore c is equals to y minus x by 1 plus xy. So here the same question we got a different answers here. So but this is the textual answer. Okay, so you may adopt any one of the these things. Okay, and let us move on to the next question, that is e power dy by dx is equals to e power y minus x. So this can be written as dy by dx is equals to e power y by e power x, because a power m minus n is a power m by a power n. So separating the variables and integrating on both sides. This is dy by e power y is equals to d power y by e power y is equals to d power x by dx by e power x. So this is equals to, and integrating on both sides, 1 by e power y is e power minus y dy is equals to 1 by e power x is e power minus x dx. So this is equals to, e power minus y is minus e power minus y is equals to e power minus x is minus e power minus x. This is equals to, plus constant of integration will be added on one of the sides. Therefore answer is e power minus x minus e power minus y is equals to c. But he has given the answer to be e power minus x. If you transpose onto this side, e power minus x is equals to this. If you transpose onto the other side, e power minus y plus c. This is the answer given. So the next question is e power x plus 1 y dy equals to y plus 1 dx equals to 0. Very first, let us transpose onto another side. E power x plus 1 y dy is equals to minus of y plus 1 dx. So now separating the variables, we get e power y dy by y plus 1, y dy by y plus 1 is equals to minus dx by e power x plus 1. So, and integrating on both sides. So, integration of. Now, this is equals to y plus 1. I'll add and subtract 1 for the numerator. Y plus 1 minus 1 by y plus 1 whole dy is equals to minus dx by, let us take e power x as a common here. So this is 1 plus 1 by e power x. This is equals to y plus 1 by y plus 1. So 1 dy minus 1 by 1 plus y plus 1 by y plus 1 dy. This is equals to minus, this is 1 by e power x is e power minus x. 1 by e power x is e power minus x by 1 plus 1 by e power x is again e power minus x dx. This integral 1 dy, it is y, minus 1 by y plus 1 is log y plus 1 is equals to minus 1 plus e power minus x derivative is 1 derivative is 0, e power minus x is minus e power minus x. Therefore, this is f dash x by f of x, log f of x. So, log 1 plus e power minus x plus constant of integration c is to be added. C can be written as log c. So, this is equals to y is equals to log 1 plus e power minus x plus log c plus log y plus 1. This is equals to y is equals to log a plus log b plus log c, log a b c, log 1 plus e power minus x into c into y plus 1. So, therefore, this is e power y is equals to, if I remove log on both sides, then it will be e power y equals to c into 1 plus e power minus x into y plus 1 is the answer given at the end. Now, so the next question is fourth one, dy by dx, tan x dy tan y dx plus tan x dy equals to 0. So here tan y dx is equals to minus tan x dy. Now, separating the variables and integrating on both sides. Then it is dx by tan x is equals to minus dy by tan y, and integrating on both sides. So this is integral 1 by tan x is log mod sin x is equals to, this is minus log mod sin y. 1 by tan x is cot x. Integral cot x is log mod sin x. So plus log c. C is the constant of integration. One of the either side is to be added. So this time I have added on the other side now. So this is log sin x plus log sin y is equals to log c. So this is log a plus log b is log ab. So log sin x into sin y is equals to log c. Therefore, c is equals to sin x into sin y is the required general solution. The next question is root of 1 plus x square dx plus root of 1 plus y square dy equals to 0. So this can be written as root 1 plus x square dx is equals to root of 1 plus y square dy. So before that, by variable separable, we get. Now, integrating on both sides. Integrating on both sides. This is equals to integral of root of 1 plus x square dx is equals to integral of root of 1 plus y square dy. So the integration of this root 1 plus x square could be compared with integral root of a square plus x square dx is x by 2 root of a square plus x square plus a square by 2 log x plus square root of a square plus x square plus c. So this could be compared with this, where a square is 1 square here. So this is x by 2 root of 1 plus x square plus a square by 2 1 by 2 log x plus square root of 1 plus x square is equals to minus y by 2 root of 1 plus y square plus a square by 2 1 square by 2 log y plus square root of 1 plus y square plus constant of integration c. This is equals to x by 2 root of 1 plus x square. This minus y by 2 root of 1 plus y square, if you transpose 5 by 2 root of 1 plus y square plus 1 by 2 log x plus square root of 1 plus x square plus 1 by 2 log y plus square root of 1 plus y square is equals to c. This is equals to x into root of 1 plus x square plus y into root of 1 plus y square. I take 2 as an LCM here, plus if I take 2 as an LCM, then log this plus log this. So log A plus log B, log AB. So log of x plus square root of 1 plus x square into y plus square root of 1 plus y square is equals to by 2 is the LCM. If you transpose onto the another side, 2c. Instead of 2c, we can replace it as c dash, and that c dash is equals to c. So this is the required general solution. The next question is y minus x dy by dx is equals to 5 into y square plus dy by dx. So this is equals to, this is y minus x dy by dx is equals to 5y square plus 5 dy by dx. This is equals to y minus 5y square is 5 dy by dx plus x dy by dx. So this is 5 plus x dy by dx. Now y into 1 minus 5y is equals to 5 plus x dy by dx. Now separating the variables, we get so this is 5 plus x by dx. It could be dx by 5 plus x is equals to dy by y into 1 minus 5y. Integrating on both sides. Integrating on both sides, we get integral dx by 5 plus x is equals to integral 1 by 5y into 1 minus 5y dy. Now, the finding the integration for this will be easy, but as far as this is, we need to solve this first. So how this is the partial integration. Okay, so let us consider 1 by y into 1 minus 5y. So first of all, this is the proper fraction because the degree of numerator is y power 0, which is 0. Here degree of the denominator is 2. So degree of f of x is less than degree of g of x. Therefore, it is proper fraction. So partial fractions can be applied for proper fraction only. Here y is the linear expression and here also 1 minus 5y. Non-repeated linear factors y and 1 minus 5y. So it could be written as a by 5 plus b by 1 minus 5y. This is equals to 1 is equals to 1 by y into 1 minus 5y is equals to a into 1 minus 5y plus b into y by y into 1 minus 5y. So cancel. Therefore, a into 1 minus 5y plus b into y is equals to 1. Now, this is equals to, here y is the linear factor, make it as 0, then one of the values of a and b we will get. In the same way, 1 minus 5y make it as 0, y 1 is equals to 5y, y equals to 1 by 5. So, y is equals to 0 and y is equals to 1 by 5 are to be substituted in this equation. So, let y is equals to 0, we get, substitute in this. Y equals to 0, if I substitute here, it would be 0. So 5 into 0 is 0, a into 1 a. So therefore, a equals to 1 we get. Similarly, let y is equals to 1 by 5 you replace and see what will happen. So 1 minus 5 into 1 by 5. 5 gets cancelled, 1 minus 5, this is 0. So b into 1 by 5 is equals to 1. So from this, b is equals to 5. Therefore, 1 by y into 1 minus 5 by equals to, what is the value of a? A is 1. So 1 by y plus b is 5. So 5 by 1 minus 5 by. So therefore, you go back to this. Dx by 5 plus x is equals to, the value of this is this. So integral dy is same. Integral dy is same. So 1 by y into 1 minus 5 by is this. So I will write it. 1 by 5 plus 5 by 1 minus 5 by dy. So this is treated as x. Integral 1 by x dx is log mod x. So this is log of 5 plus x is equals to, this is 1 by y dy is log y plus this is integral 5 by 1 minus 5 by dy. Okay. So 1 derivative is 0. Minus 5 by derivative is minus 5. Therefore minus 5 is what I require. So minus of minus I will write. So this is minus 1 minus 5 by derivative is situated on the numerator. So this is f dash y by f of y, log f of y. So this is minus is there, log 1 minus 5 by. So that is equals to, plus constant of integration is log c. This is equals to log 5 plus x is equals to, this is log a plus log b. So log ab cy minus log 1 minus 5y. Log a plus log b, log ab minus log 1 minus 5y is same. Next, log a minus log b, log a by b. So this is log cy by 1 minus 5y is equals to log 5 plus x. Therefore, 5 plus x is equals to cy by 1 minus 5y is the required solution. dy by dx equals to xy plus y by xy plus x. So here, dy by dx is equals to, if I take y as a common here, then it is x plus 1. X if I take common, this is y plus 1. So here, separating the variables, we get, this is y plus 1 dy by y is equals to x plus 1 dx by x, integrating on both sides. This is equals to y plus 1 dy by y. So y gets cancelled, 1 dy plus 1 by y dy is equals to x gets cancelled, 1 dx plus 1 by x dx. This is equals to integral 1 dy is y plus 1 by y dy is log y is equals to 1 dx is x plus log x plus constant of integration c. So this is equals to y minus x is equals to log x minus log y plus this c can be replaced as log c also. Now this is log a plus log b, log ab. So log cx minus log y, log a minus log b, log a by b. So log cx by y is equals to y minus x is the required general solution.